This question here, we're doing the same thing we did with the other ones. So what would be a good first step if we want to separate those variables? Okay, so, whoops, this is glitching for a second here. So you're going to times by the dx, and that'd get the dx over there, and then times by this. So that's the same as like cross multiplying, isn't it? So I'm just going to cross multiply here, but same thing as what you said. Okay, so if I multiply these two, I get 6x squared dx. And then multiply this piece here, and I get that 2y plus cosine y with the dy. And then what do I do with both sides? The antiderivative, we integrate it, right? So you put an integral in the front. Oh, well, that was my left hand, so I was really nervous. Okay, now we do antiderivative. So the 6 kind of just hangs out. The x squared turns into x cubed over 3. So what's that going to turn into altogether? 2x cubed. And if you take the derivative quick, you can see that you did it right. You need a plus c on one side or the other. I'm going to put the plus c on this side because it's the x side. That's usually the one I put it on, but it doesn't matter. And then the 2y turns into what? Just y squared. Cosine turns into sine. And then we don't need a plus c on this side. Yeah. Yeah, so the integral and the dy are just like notation. Just think of them as that. It just means take the antiderivative of what's inside of there. So when I take the antiderivative, the integral goes away and the dy goes away. Same thing over here. The integral goes away and the dx goes away. Kind of. They're like a pair. It's like what's in between those is what you're doing the antiderivative of. Okay? It's just like notation. Okay, now is this going to be easy to solve for y equals? It's not even really, I mean, maybe it's possible, not that I know of. This isn't even possible to solve for y equals, so don't waste your time. So right now, just on the AP test to review, we get a point for separating the variables, so you get a point for here. You'd get a point for taking the antiderivative of the x stuff, a point for taking the antiderivative of the y stuff, and a point for putting plus c. So right now, you're at 4 points, okay? Sometimes you get a point for solving for y. You wouldn't get that in this problem because you can't solve for y. But then you're going to get a point for this here. Okay, it says it satisfies the y of 1 equals pi. So this is your initial condition, and we've worked with these before. This is saying that my x is 1 and my y is pi. And what you do is you plug that in and solve for what the plus c is. So I'll give you guys a minute head start there. Okay, so when we plug that in, our x is 1, so this is just 2 plus c. And then over here, this turns into pi squared. And then what is the sine of pi? 0, so that goes away. And then to solve for c, you subtract the 2 on over. So our c is equal to pi squared minus 2. Questions on that? And then to finish out the problem, some people forget to finish it out, you plug it back into up there. So we have 2x cubed, and instead of plus c, you put plus pi squared minus 2. And then that equals y squared plus sine of y. Questions on that? So really, I think this question's easier than the question before it. This question's definitely difficult. The only thing on this question that you probably wouldn't see on the AP test is having to factor that to begin with. Not that it wouldn't be fair game, but I don't think that they would test that portion. They'd want to see if you can do the rest of it, so they'd probably give it to you in factored form. Okay. I'm going to give you guys some time on that.